Okay, so now we're going to talk about the orbital shapes. We have S, P, D, and F. S I call spherical. It has room for only 2 electrons. It's technically called sharp, but you're rarely ever going to hear that term. P is sometimes called polar. I refer to it as a dumbbell shape. It can hold up to 6 electrons. Its formal name is called principal. D is a double dumbbell and dumbbells and donuts. That's what I'll refer to it as. It can hold 10 electrons. It is your transition block. Formally, it's called diffuse. And F is more complex. We generally say it holds 14 electrons. It is your inner transition metals. It's also called fundamental formally. Okay, the reasoning behind the shapes. This is all based on math. It is based on their angular momentum and that the electrons will have. Remember Schrodinger and Heisenberg? We talked about those two gentlemen. The idea is you can either know the velocity that the electron has or you can know the position, but you can't know both. Okay? And so with this reasoning, we produced shapes like this. And you may be looking and going, what in the world is this? Well, first of all, this is right here. This is your S. It is spherical. Based on math and physics, energy, it is the lowest form of energy, that is the lowest shape. That shape has the lowest amount of energy attributed to it, which is why it's spherical. These are your P block. Okay? And that's what I refer to as dumbbells. These shapes basically is the highest probability where you'll find an electron. That terminology needs to become part of you. Again, it's not like we're going to say the electron is right there. The darker areas represent the highest probability of finding an electron. And the only difference on the 3 here is the X, Y, and Z. It's how it's orientated into 3D. Okay? Here's your D block. Remember I talked about the donuts? There's your donut right there. Okay? Again, it's all designated by how they arrange themselves on the 3 axes. The final one is the F. And as you can tell, it gets way more complicated. And there's your double dumbbell donuts there. So this is what they look like. Again, it's all based on the arrangement of X, Y, and Z on the 3D axis. So let's take our periodic table, the new one, and let's make some colors. So we are going to color our P block. Our P block is basically group 1 and group 2. You notice that I went ahead and I blocked that over there, because guess who goes right there? That's right, helium. So we're actually going to remove helium from over here and bring it over here next to hydrogen. Okay. And so all of these people take on the S shape, or the spherical shape. And then we have the P block, where we talked about boron, aluminum, gallium, indium, thallium, and how we got that bump on the data we looked at. Well, that's why we got a bump, because these take on their own orbital shape, different from the S block and different from the transition metals, which is why we got what we got. And then we have the D block. The D block is our transition metals. Again, if we go back to our data, we saw that there was a change, especially right there at the end. That's where the highest ionization energy was. Oops, I labeled that wrong. I'm so sorry. This is the P block. My apologies. This is your P block. This is your D block. These are your double dumbbells. These are just your dumbbells. And the last thing we have is our F block. And there you have it. S, P, D, F. Spherical, dumbbells, double dumbbells and dumbbells and donuts, and very complex. Thank you and have a great day.